Hello Year 12, welcome to the next video here, number 2, for our third topic, which is graphing lines. Now in the first video we looked at all sorts of things, but quite specifically we looked at identifying linear functions, righto? So that's y and an x, no x squareds or anything like that, no xy's, no 2 over x, any of that sort of stuff. Right, something like y equals 2x plus 1, nice and regular. It's going to be a linear function. If I seek the graph of it, linear function is going to be a straight line. Wonderful. Okay, so we looked at that. We also looked at recognizing some attributes, some sort of qualities of that linear function. Specifically, we looked at finding the y-intercept and the gradient. Right, the y-intercept is where that straight line crosses the vertical axis, or the y-axis, and the gradient being the slope or steepness of that line, which is how much it changes every time I go 1 unit to the right. Okay, so that was the first video. There was quite a lot to be done there. The second video here is a bit more straightforward, a bit more practical too, I suppose. So what we're looking at in this activity is a thing called linear modelling. Okay, modelling is just when we use maths to try to replicate some real world situation. And in this case, linear modelling, because we're using linear or straight line equations. Okay. So here we have an example. Carla has a window cleaning business. It costs her an average of $75 a day for fuel and vehicle maintenance and $8 per job. Okay, so every day it costs her $75 no matter what, and then it costs her an extra $8 for every job she attends. Now obviously this is not taking into account Carla being paid, this is just her costs, right? So $75 plus $8 per job. We're going to have C equals Carla's daily costs and N be the number of jobs she does each day. Now we need to write a linear function for Carla's daily costs. So we want it to talk about Carla's costs. So for part A here, it needs to look like this. It has to be C equals, right? How much does it cost Carla per day? Well, it costs her $75 plus $8 per job. So that's 8 times N for the number of jobs. Okay, 75 plus 8N, or just because we like this sort of way of doing things, C equals 8N plus 75. That's just a slightly more standard way of doing it, where we have this variable, in this case N, first, and we have the constant, that's the number without any letters, we have that second. Rightio. Now we're going to graph this. We need to draw up a table of values. If you get confused which one goes which, think of X and Y, right? It would normally be Y equals something, and when I draw up a table of values, right, which is going to be very helpful for part B here, normally be X at the top and Y at the bottom. So we're going to have a table of values with N at the top and C underneath, because we use N to calculate C. So how many of these do you reckon we want? 0, 1, 2, 3, 4. That Lewis? Right, let's try this out. Okay, so let's go for N equals 0, 1, 2, 3, and 4. Okay, now if we know that it's a linear function, just 2 points will be enough to do that. However, third point gives us a bit of a backup, gives us a check, and it's not going to hurt us to have a third and a fourth and a fifth as well, right? It won't take too long. So here's our formula. C equals 8N plus 75. So take N, multiply it by 8. 8 less 0 is 0, plus 75. Okay, so we've got 0.75. 8 times 1 is 8, plus 75 is 83. 8 times 2 is 16, plus 75 is 91. 8 times 3 is 24, plus 75 is 99. And 8 times 4 is 32, plus 75. 32 plus 75 is 107. There we go. So we have 4 points here. I need to graph these. And we're going to have a little bit of problem here because obviously my 75 is fairly big, right, compared to my 0, 1, 2, 3, 4. X would normally go on the horizontal axis. We're going to mark these off first, right? I'm going to go right to the corner here. Right, we don't really need to go to the negatives because Carla can't clean a negative number of windows, nor is she going to pay, or is it going to cost her a negative amount of money. So let's choose nice generous numbers here. I'm going to go 1, 2, 3. 1, 2, 3, 4. There's a reason this stuff is called grid paper or graph paper, because it sure makes drawing your graphs that much better. Okay, now you should use a ruler and a pencil. I have neither, but I have got a grid underneath to help me along the way. So this axis, we need to label that as N, okay, because that's what it's describing, and that of course is 0, 1, 2, 3, and 4. There's our horizontal axis, and I know that I've got a point that's going to go somewhere above each of those little marks. Now I need to make it to go all the way up to 107. I think I've got 20 spots here. 20 should have been just over 20. Should have gone for 21 or 22. Right, well let's say that... Oh, look, we'll just do it like this. Let's say each one of these counts for 10. Okay, so that's going to be 10, that's going to be 20, 20, 40, otherwise it's just not going to quite fit. 60, 80, 100. Oh, I don't have 20 of those, I don't know what I was thinking. And that's, it's 100 and 110. Rightio, so there is our vertical axis, which we're going to label with a capital C for cost. Rightio, there's our two axes. Now we need to put some points on here, and I have 0 and 75. 60, 70, 75 is here. My next one is 1 and 83. Okay, 1 and 83 will be about here. And then we've got 2 and 91. Yeah, 2 and 91 is about here. 3 and 99. About here. And 4 and 107. Okay, and if we've drawn this well enough... Oh, no, I've made a mistake there. I wonder if it doesn't go there. And of course that's not 110, that should be 120. Stanwell. There we go. So my 4 and 107 should be more like about here. Okay, and that's one of the advantages here of putting viewpoints in, that it does make it a little bit easier to see one that's fallen out of line. So a nice straight line, if I could draw such a thing. Nice straight line here should go through all of those points. Don't do a big squiggly line like this, use a ruler and a pencil. But nonetheless, there is my linear model. How do you like that? Rightio. So that shows me roughly what it's costing Carla, depending on how many jobs she does, how much her costs increase. Frankly, I would look at that and say sort of not that much. The big expense is the starting off 75. After that, you know, a few jobs, it's not getting a lot bigger all that fast. Anyhow, let's move on to part C here. What is the gradient and vertical intercept of the graph, and what do these values represent? Well, the vertical intercept is easier. My vertical intercept is, right, this point here, which is $75. And this is, or it represents, what we might call Carla's fixed costs. No matter how many jobs she does, it's always going to cost her at least $75. Now, let's see. 1 point, point 1, point 2 here. The gradient. Well, I need to know how far, every time I go across one step, remember one step is this far, how far up does it go? Every time I go across one step, how much up does it go by? Every time I go across one step, how much is it going up? Well, each step you can see from here to here is plus 8. From here to here, plus 8. Here to here, plus 8. And of course, I can also see that from that number there, the coefficient of what would normally be the x term, the coefficient of that variable there. That is my gradient. So the gradient is 8. We can in fact say it's $8. This represents the cost of one job. The cost per, we could probably say the cost, yeah, the cost per job. Okay, so we've got a fixed cost plus a cost per job, and they correspond to the vertical intercept and the gradient. So that's linear modelling. Keep in mind what you want to do here is that you want to, 1, write the equation, and that can be a little bit tricky. 1, write the equation. 2, draw up a table of values. 3, draw a graph. That's how we're normally going to do these things. And if you don't have x's and y's, just try to match them up in the same way, right? Where x goes up the top of your table of values, and it goes across, because it looks like a cross, goes across the bottom of your graph. Rightio. Thanks very much, Year 12. See you in class.